Hello. In the last class, we have seen about electric dipole and also dipole moment. In this class, we will see if an electric dipole is placed in a uniform electric field, what situation it is in. I will give you a question and we will try to solve this question. So, by solving that question, we will understand if a dipole is placed in an external field, what happens. The question goes like this. An electric dipole is placed in a uniform electric field E. In a uniform electric field E. Deduce the expression for the torque acting on it. An electric dipole is placed in a uniform electric field E. Deduce the expression for the torque acting on it. By understanding the question, we will know that when a dipole is placed in the uniform electric field, there exists a torque. And we need to find out the expression for that torque. Now consider an electric dipole consisting of two equal and opposite point charges separated by a small distance 2a. So we will consider an electric dipole consisting of charges minus q and plus q. Minus q separated by small distance 2a. Having dipole moment P equal to q into Ta. The magnitude of dipole moment, so this we have done in the last class, P is equal to q into 2a. Now we will draw this situation. So let us say this is the electric field, uniform electric field. So the dipole is placed in a uniform electric field. Let me say this is the direction of the electric field. This is E. In this direction. And let me say the dipole is placed in this uniform electric field like this. Minus q and plus q. Now there is a force. When a charge is placed in an electric field, there is a force acting on it. The force acting on plus q is q into E, and it is acting along the direction of E. This is the force plus QE. And there is a force acting on the charge minus Q, which is equal to minus Q into E, and it will be away from minus Q charge. Minus Q into, so it is the direction is opposite to that of the electric field. Now there are two forces acting here. The net force on the dipole is 0 because plus QE and minus QE, they are equal and opposite. The net force on dipole is 0. Important, when a dipole is placed in a uniform external field, the net force on dipole is 0. However, since this charge is separated by a distance 2a, it is given. So because the charges are displaced by a distance, so the forces are acting at different points, so this results in a torque. Our question is to find out the magnitude of that torque. So let me say this dipole makes an angle theta with the electric field. So dipole is placed in a uniform magnetic field, uniform external electric field, not magnetic field, sorry, uniform electric field, such a way that it makes an angle theta with the direction of the electric field. So theta is the angle made by the dipole with respect to the external electric field. So force on plus Q is force on plus Q. Force on plus Q is Q into E plus Q into E along the direction of E. Force on minus Q. Minus Q into E, and this is along the direction opposite to E, along the direction which is opposite to E, or I can write in an opposite direction of E. In an opposite direction of E. In an opposite direction of E. Now these two forces being equal, unlike, and parallel to each other form a couple. So that means there exists a torque here, and this torque rotates the dipole in clockwise direction, and it will try, the torque will try to make this dipole align to this electric field E. I'll write here. So the forces being equal, unlike, and parallel form a couple. It rotates the dipole in clockwise direction, tending to align its axis along the direction of the field. It rotates the dipole in clockwise direction tending to align its axis along the direction of the field. Therefore, torque is given by force multiplied by arm of couple. Arm of couple is the perpendicular distance between the forces. Force multiplied by, that means magnitude of any one force multiplied by perpendicular distance between the forces. Perpendicular distance between the forces. Now in the figure we will see what it is. The perpendicular distance between the forces is, if I mark this point as A, this point as B, AC. So the perpendicular distance will be AC. Now this angle is theta. The angle is theta. So sine theta is, I can write here, sine theta is AC by 2A, or AC is 2A sine theta. AC is 2A sine theta. Force multiplied by perpendicular distance between the forces. Now we can write force is Q into E multiplied by AC, which is QE into AC is 2A sine theta. Rewrite this equation. Q into 2A into E into sine theta, and we know Q into 2A is P. PE sine theta, because P is Q into 2A. So torque is given by, torque is P E sine theta. In vector form we can write into E, P cross E. Remember, when a dipole is placed in a uniform external field, the net force is equal to 0, but there exists a torque, and the torque is given by PE sine theta.